everybody. So today we are going to be making a Ferrari Emblem with the DMC2. This video was actually filmed like a year ago, and I'm just sort of getting around to editing it now. So I'm going to take you on the journey here, all the twists and turns, and we'll see how this here turns out. Okay, so I just want to run through what I did for some of the programming on this, just because it might be of interest to people who are new to this, especially doing this type of thing, because it's a little bit different than certain other types of engravings that you might come across. So for this, ignore the hexagons that I have here. This was something that I thought I was going to do, and I chose not to cut those out. But these are all the files that I use, and basically I just skipped over the ones that would cut the hexagons, because that was just an extra step. But what I did is I faced off my part, and of course I had a facing operation. I created another setup, and first thing that I did for my major clearing was adaptive. Now, if you've done things with like F-carve, then you can have pocketing operations and you can have parallel clearing operations. On smaller pieces, sometimes it makes sense to do parallel clearing operations, but if you have something like this, especially where I'm going to paint like the background bottom, it's much quicker, much quicker to do an adaptive tool path with a size tool that will fit in and around most of your contours and things. So basically I'm just doing a basic adaptive path, and actually maybe let's just take a quick look. And I'm running very conservative feed rates here, because you will see in some of my testing that I did in other couple videos there that I was able to run like 2,000 millimeters a minute. But just for easy going, I usually aim for about 0.02 millimeter in my feed per tooth, and that gives me very safe, accurate results without much problem. So you can see the chains that I selected in here to get this to pocket out, and having to select all of this was key in order to get it to work. And my heights, because the contours that I selected were the top lines, I put in here how deep I wanted it to cut. And then in here, of course, your optimal load, that's basically your step over. But you see, not a whole lot going on there. And my helix, you just got to make sure that this is small enough that it can ramp down in some open portion here. And one thing that I will say that I tend to do now is always use high feed for my retracts. Only because you can either do it this way, or in Mach 3 you can restrict how fast the z-axis will retract. But I've found that if you do a full speed retract, every once in a while you can sort of run into problems where it could lose a step or something like that. I just find where I'm able to run higher feed rates with the DMC2 anyway, that I'm better off just doing high rate of feed, and really the time lost for these one-off pieces, it's not that much. So anyway, that's that adaptive, and that was exactly the same. And I had to create a few different adaptives, you'll see here, like to get that little space in there, because the way that the programming has to be done to get this to work and get all these little spots is different from this big area. And that would have been the pocketing, I guess, for those. This here, I had to do a pocket operation for this, not an adaptive. And the reason for that is to be able to get around all of these shapes. I couldn't get the tool to go in and cut. Like when it created the cut profile for this as an adaptive, this outer portion, it was missing a whole bunch of spots, and it didn't want to do this channel that's out here. So it made way more sense to do it as a pocketing operation. So that's all well and good. Then we switch over to our V-bit. A V-bit is essential for doing this. It's one of our most important tools, and I'll show you a little bit of what I did here. Nothing big here, I just did a V-pocket there. The contour, this is where we really start to sort of finish off our engraving. So around, the horse here and our lettering, all pretty simple, all pretty standard. I will bring this up just so you can sort of see some of the settings that I was using. And I think I actually did end up speeding this up. I don't know why I never changed it in here, but you can run this at a fairly decent speed. And you can see the parts that I selected. Nothing major there. And again, -0.75. I didn't even offset it on this one. Sometimes I will, but I didn't on this one. Yeah, all pretty standard. And I think what I did in mock, I just did an override for my feed rate and upped it, because really, if you've done everything else correctly, this V-bit's just going around and just hitting the edges of this to clean it up. It's not removing much material, probably little enough that you really wouldn't even need the flood coolant, but I have it there just in case. Because in certain circumstances, you won't have removed enough of this material in these tight spots, even with the 2mm end mill, so you just have to watch out for that. Okay, so the pencil. This is an important technique on here to get some of these other features that you see. And the thing with the pencil, and this one, it's kind of difficult to program, or can be difficult to program, to get it to do what you want, but I wanted the features in this main to sort of be highlighted, and you'll notice that the contour, it sort of went around the outside of all this. The pencil is a 3D operation, so it will move up and down in the z-axis as it moves along, which allows it to get into all these little cutouts, and also to do these sort of features here that are on the horse. The one thing you have to watch out for with this tool is that for some reason it does not want to pick up the V-bit in its transition to certain other cut points for whatever reason. I have no idea why this is, and I had to play around with this quite a bit to even get it as good as it is. But the way that you combat this is actually, when you go to set your Z height, just make sure it's just a little bit above your top height. And when this goes across, it should miss this top piece. Not by very much, but it should miss it. And even if it does, where I know that I'm going to be painting this bottom section, I'm just going to be painting the whole thing and then sanding off the top layer so that this is all just the color of the raw aluminum. It's not a big deal if it does touch, because it's just going to be a little tiny scratch, and that's just going to sand off when I take off the paint. And I also did the pencil function around the Ferrari logo, or the Ferrari letters up here, just to try and clean up a couple of the spots, like in the corners of my letters, where doing a contour around it doesn't hit all those little spots. And there are a couple little weird things here that it'll generate in there, but it just doesn't cut anything, so that's not a big deal. But I do need that operation to be able to get down inside and cut out some of these corners in the letters to really clean this up. This one was a little bit more difficult in that regard, in that I had to do that. Most of the ones I've done, I don't have to. Most of my cleanup I can do with this next step, which is an important one, and this is parallel cleaning, or it's using a parallel tool operation. And if you've used F-carve, this basically takes the place of parallel operation, is what it's doing in F-carve, to clean stuff up, get into the spots that your flat end mill can't. And I did this in a few different operations too, because settings had to be slightly different in order to get this to work. But you notice, like in around here on the horse, we want to clean up some of these little areas. We don't want little mountains of aluminum sticking up. And in and around the logo, or the letters here from the logo. And then we have another one here, and that was doing this section up in here and cleaning up around the letters. That was important. So actually, let's go and take a look at this. So you notice like my additional offset, my 0.05, you can read what that's going to do, but the reason why I've chosen this value and why I use that value is to keep it off of what I've already engraved and keep it from nicking the contour that's there. When I was trying to figure this all out like years ago with my other CNC router, that's how I sort of came up with this number, and I just transferred it over and it worked. And of course I'm doing rest machining because I don't want it to go around and do everything that I've already done. We did model surfaces, but I also did parts to ignore, or that I don't want the tool to hit. This is another important thing to do with these types of operations, because if you don't, this parallel clearing operation, when you're trying to hit these little bits that are in tight, it can sometimes go in and take too much material out, or go somewhere where you don't want it to go, or it'll try to cut some of these other features. You don't want it to. So by selecting that and keeping that, as the tool to keep away from and avoid, we keep it from going places that we don't want it to go and cutting stuff we don't want it to cut, basically. And so for my bottom height, I will make a note here that I selected this bottom portion as my face. That's why I didn't have the negative 0.75 millimeter for this one. That's what I was trying to find. And my step over, 0.01 millimeters. That's important too for this clearing operation for a V-bit. I found that works quite well. Leaves fine enough lines that a paint fill will fill it. And or if you're just going to leave it as raw aluminum, it actually looks quite nice. So there is that. Or sorry, that was minimum step over. My actual step over is 0.1. If you want to get down for 0.07 can look really nice too. And if you want it to be really, really fine so that it's not even noticeable, 0.05, about half this, can be very good. But where I know that I'm going to be painting this, 0.1 works perfectly fine. You want to make sure you have both ways. And again, stock to leave, I found that having that 0.05 in there just sort of helps me out to keep it off of where it's already cut the contour, because remember, we're just cleaning up the little mountains that are in between. And other than that, yeah, all pretty straightforward. So it would have been the same for this one. I believe, let's just quickly go through, yeah, 0.05. Avoid surfaces would have been different. So the reason for splitting these up is so that my contour selections and my floor selections, I can sort of separate those from the last operation. That's the only reason for it. All the other settings should be pretty much the same. And I see I did a 1 millimeter fillet radius here. That would have been for around my letters and stuff to give them, I guess, a consistent sort of bevel to them. And because too, again, I don't need to get in real close. I don't want to interrupt what I've already cut. That was just a way, I guess, to offset the tool. And a big part of that too is getting this area down in here, because you'll notice back when we did the original contour that we had material left there. And then I was just cleaning that out. I did that with a parallel clearing operation, and then we just cut the piece out with a 2 millimeter flat mill. So anyway, I think I covered everything I wanted to cover there. Hopefully I didn't buzz through too fast or do that in a confusing way. Hopefully that sort of makes sense. But I guess the reason why I wanted to cover this is, like, some of these settings in Fusion 360, because of the way it operates and because there's so much that you can do with it, sometimes you got to input certain values to sort of trick it. Some of those offset values, actually what it does is it keeps it away from parts that you don't want it to cut. So you're sort of tricking it into cutting things that you do want it to cut. Hopefully that makes sense. And yeah, at the end of the day, as long as you get the results that you want, that's what counts. I'm sure that the Fusion 360 experts out there would have a heart attack looking at my programming, but for me, for this type of stuff, it works. I've done this for a bunch of different emblems now, doing this style of cutting, and it works out really well. Now, this is different from the other type where you use like a ball end mill and, you hit a circular pattern like on your 3D milling operation, and it'll just go around and it'll cut all this out. That is a different look, that's a different type of milling, and you have to have a fairly fine mill to be able to get in and get all the detail that you need to get and not have a bunch of rounded over edges and stuff. So just keep that in mind, even though there's quite a few, well, there's only two tool changes, I guess. Well, 3 for the final cutout. But once you're up and running, like if you had multiples of this to do, this is actually a fairly quick operation. You set the machine up, let it run, and you can actually, once you know that all of these tool paths work, you could actually, all the ones that you're using the 2mm tool for, you could export those as all one operation. And yeah, it's just quick and easy way to do it. It comes up with a really nice engraving that I've gotten really great feedback from people on. So anyway, that's it for that. Thank you for watching this video, and we'll see y'all next time.